Good morning and welcome to Tech Talks. As always, to start off with a bit about COVID, always wear a mask out when out in public. Wash your hands with soap or alcohol-based hand sanitizer. Avoid touching your eyes, nose or mouth with unwashed hands. Avoid close contact with people who are sick. And cover your cough or sneeze with a flexed elbow or a tissue and throw into the bin. And clean and disinfect frequently used surfaces and objects. This morning's topic is drainage in Dolomite areas, and we want to share a couple of different thoughts and also methodologies on it. We're seeing more and more in bills of quantities is that Dolomite areas are becoming more important with the engineers, and the sort of specifications that they are putting together and what they're asking you to do. And then we're just going to start off, as always, the basics of drainage. The most important thing is to make sure that you're taking care of the air. In any drainage system, your air is the most important part, is to make sure that your fluids and solids are not filling up the pipe, making sure that you've got the right ratio of air. And ideally is that you need to make sure that your pipe is between 50 and 80% full. And this is to ensure that the drainage is, and the pipes are scoured properly and it drains all of the solids away. Drainage in Dolomite areas and water leaks in areas where there's dolomite is quite a scary thing. And if you've ever seen any of the sinkholes around Carltonville and some in Midrand, and a lot in Pretoria, is you'll know that the ingress of water into any dolomite area is a real problem. So a little bit about the SANS 1936, and it's quite a long document, so I've just pasted a whole lot of the pages, and I've highlighted areas that are important or relevant to what we're talking about. When we talk about a rational design, we often talk about the competent individual and who is a competent individual. And obviously a plumber, when he is qualified and he has the experience, he is deemed to be competent. However, in Dolomite, it is very clear that the plumber is not the competent person. Just a couple of the points from what's important are sinkholes, what is suitable, and what are wet services. We're not going to dwell too much on these things because otherwise we're not going to get finished. So the competent person, requirements of a competent person is that it's an engineer and a geo-professional. Is that it's no good to be it's not sufficient just to be an engineer unless you understand geology and what is happening with the Earth's surface and what happens when you are dealing with dolomite, and especially when you are getting an ingress of water into it, what can actually happen. So the first important one is the design and the associated inspection during construction of buildings and structures of parcels of D2 and D3 dolomite. So if you were to look on the web, you would find a lot of maps that actually show you which areas are dolomite. And if you are doing drainage or water supplies in those areas, it's important to make sure that you're using the correct material. The design methodology is that the design of buildings, structures, infrastructure, and related wet and dry engineering services shall be carried out by a competent person, an engineer. The design shall comply with the relevant compulsory specifications and the relevant national legislation. So that's quite an important thing, is that the plumber just can't go and do what he wants. If he's used to using a certain product and he's priced for that and he doesn't use the correct products, is that you, in theory, should become liable. So wet services that we are talking about today is sewer mains. And the sewer main shall convey sewage from the waterborne sanitation system to the bulk sewer infrastructure in a manner acceptable to the local authority. And a lot of the local authorities are quite jacked up when it comes to dolomite areas. and they'll make sure that you are doing the right thing. So the sewer main shall be an appropriate degree of reliability and within the established parameters. They must withstand all the loads and pressures to which they are likely to be subjected, be capable of receiving sewage from waterborne sanitation systems, carrying the design hydraulic load and discharging into a local authority bulk sewer infrastructure. They need to be watertight, and they need to prevent rainwater from entering the system and be accessible to clean and monitor and maintain. So it's pretty much the basic stuff that we're supposed to do with all drainage installations. A lot of this stuff, as I said, you'll be able to go back and read it. We're just going to touch on the ones that I felt were important. The ability to reliably withstand all direct and indirect actions and forces, including those relating to potential loss of support, to which the system is likely to be subjected over its design working and without losing functionality. And to have the ability to withstand differential movements and remain watertight. And what we see quite a lot is that where contractors are putting in drainage and they've over-excavated 100 mil or 300 mil, and they put soft soil down and then they just lightly compact it or just rake it to the correct level. And obviously, as soon as that gets any sort of moisture in it, the fines are going to wash down and you're going to have a slight collapse. And that collapse doesn't need to be much. It can only be 50 mil, 100 mil, and then you'll have problems with your drain. Obviously, when you start looking at how much a pipe subsides, is the stresses that are put on the joints and will the joint fail. So from this is that the long-term reliability of the jointing system, even if lateral vertical movement takes place. So no matter really what happens with the excavation, is that your drainage installation is supposed to be able to withstand that. Probably the most important part is the workmanship, quality assurance requirements, and the availability of suitably skilled artisans to execute the work. In terms of the design specification, and install all components of the service in accordance with the manufacturer and competent person's specifications. And we need to make sure that we have quality and manufacturing consistency. And this again is making sure that when you're putting the product in, that it's from a reputable supplier and it doesn't have regrind and all sorts of bits of plastic put into the pipe manufacturing process. So in a Dolomite area is that the engineer will determine is that what sort of distance your pipe needs to be able to span if there is a sinkhole. So it goes from 2 to 15 meters is what is need to be able to be in the excavation or in the ground, and it must still remain integrated with once we've had a collapse. So in other words, if we have a sinkhole of 15 meters, is that the pipe needs to be able to make sure that it doesn't collapse. So the Dolomite specification that was put together is quite an old document, and there's a lot of technology has changed quite a lot. We'll see that the wet engineered services should, wherever possible, not be placed parallel to buildings unless they're at least 5 meters away. And then, of course, they qualify that by saying if the stand size allows. So a lot of the sort of lower bonded houses and affordable houses are built on Dolomite areas. And obviously the cheapest product is the one that is normally used there. And a lot of those stands don't allow for your drainage to be 5 meters away. If you were to look at conventional drainage installations, is that your drain should never be at an angle of 45 degrees below, or must be at an angle of 45 degrees below the foundation. So if your drain is 2 meters deep, it needs to make sure that it is far enough away from the foundations to make sure that if something did happen, it wouldn't affect the foundations. So clause 6.2.17 is quite a difficult one. So say wet engineering services systems may only be placed beneath the footprint of a building where such services are placed in a sealed sleeve, a watertight duct or drainage channel, which drains towards a point where any leakage of the wet engineer service can be readily detected. And then the sleeve shall comply with the requirements for sewer design in Dolomite areas. So basically what they're saying is that you need to make sure whatever piping you put in underneath the foundation or underneath the structure is housed in another sleeve. And time again, we see is that outer sleeve or the inner pipe always gives a problem because they are not done properly. You know, the competent installer is the real challenge. Having all of your junctions underneath the ground, underneath the footprint of a building, like in a shopping center, is you've got to put those into a chamber to make sure that they are actually properly sealed. So this goes away from the norms of a normal manhole, is that you don't have channels and junctions, is that you have a watertight box and your junctions are then housed in that. Obviously in a shopping center or a big development is that you don't want 300 pipes exiting the side of the building, so you don't want to take them all out individually, because that creates an even bigger problem, is that you've actually now got 90% of your floor area is now trenches. So table 5 gives us the piping that they recommend in Dolomite areas for sewers, and all diameters are high density polyethylene, PE 100. They always make quite a big fuss about the PE 100, and PE 100 is now the norm in HDPE for drainage and water. The PE 80 has pretty much been stopped. They stopped manufacturing that. They then say that it's an SDR 17 or PN 10. So PN 10 is a class 10 or a 10 bar rated pipe, which is quite a thick wall. And often is that we see that that is going to be 100 millimeter or 110 mil diameter, which gives us then about a 90 millimeter ID. And 90 millimeter ID is sufficient when you're taking off 1 or 2 toilets. And very often is that when we're looking at the design of drainage is that we want to reduce the size of that drain. But when we are taking bigger hydraulic loads, the 90 mil becomes problematic. So often then you need to go up one size. And then pipes shall be supplied in minimum lengths of 12 meters. That's more of a comment than a requirement, because once you put in the thing together and you're going to cut in your junctions, or you're going to put in the system, it's very seldom that you're going to use a couple of 12-meter lengths. However, is that when you're doing the mainline drainage, that obviously makes a lot of sense. Polypropylene, that's also an acceptable product, also PN10, and the jointing method for both of these is butt fusion, electrofusion, or hot gas extrusion welds. The hot gas extrusion welds are very common when we manufacture fittings. One of the challenges again is the quality of the manufacture, and making sure that you don't have any ridges or big gaps in the joint of your manufactured pipe. So butt fusion and electroweld is definitely the way to go. Then UPVC class 34. And those need to be with mechanical devices consisting of sealing rings or grooves, or both, and clamps. So it's a little bit confusing with the sealing rings or grooves, is that, are they talking about a rubber socket? And if that is the case, and you have a subsistence of a couple of meters, is that it's going to pull out of the socket. So again, a little bit of a challenge. And as always, everything has to be tested and made sure that everything is watertight. If we're going into a D3 Dolomite land, the nominal pressure rating shall be 1 pipe designation or class higher. So in other words, if it was a PN10 and you're going to go into a D3, you need to use a PN12. So again, a lot of information for you just to read at your leisure. Additional precautionary measures in Dolomite areas, designated D3 sites. So they'll comply with the following requirements in addition to those established in 6.1 and 6.2. The preferred pipe type for all wet engineering services and sleeve systems for such services on Dolomite Area designation D3 sites is polyethylene, and they will comply with the material manufacturing requirements of a PE 100. Jointing method would be by butt welding or electrofusion, and they talk about straight lengths or rolls of 50 and 100 meters, and I would dread to see when we're using rolls of HDPE for drainage, you're just not going to get a great system. So when they talk about is that the pipes need to be sleeved, is they're talking about a containment pipe. And in order for it to be able to span the distance, especially under like a shopping center surface bed, is that we'll use an outer pipe of 160 mm PN12, and then we'll use 3 spaces which are welded onto the inner pipe to give us support along the segments of the pipe and to ensure that we keep our centers and inverts correct. And then when we backfill in that pipe, we put a stainless steel strap around it, which we then take up to the surface bed level, and that will be secured to the rebar. And this allows that if the section under the surface bed was to collapse, is that the pipe would still be suspended from the surface bed. So what does that look like? Is that our outer pipe would be the 160, and a lot of the engineers, as I say, this document is an old document, and they're starting to look at the other products that are available. So we're using a PN10 or PN12 outer. Then we use a 110 HDPE drainage pipe, so similar to the Geberit HDPE. And onto that pipe, we weld these 3 spaces. And that allows the pipe to be turned in any direction, and you'll always have the invert will be correct, is that it fits quite snugly into the 160. The welding of this then obviously becomes problematic, is that the butt welding doesn't work that well because you can't butt weld both pipes. And we found when we've tried to weld the 2 pipes together is that we have a lot of failures with the workmanship of the guys welding on site. So typically top left corner, 160 PN12 in the trench bottom, and you can see the stainless steel straps where it is hanging from the reinforcing. Obviously that reinforcing will only go in after you've backfilled and the surface bed preparation has been done. Once we've laid the 160 pipe, is the picture below that with a yellow squiggle around it, is we insert the 110 pipe into that pipe. We then take the next section of 160 and we leave a gap between the 2. We then push the second 110 pipe through, and we've got an electroweld coupling on both pipes. You can see the 160 electroweld coupling is already prepared and scraped and put onto the one side of the 160 pipe. The 110 is then pushed through, and we then mark and then scrape the 110 pipe. And this is a really important part because you need to make sure that you've got that oxide layer off before you do the weld. We then push the 2 110 pipes together, and we then carry on with the electroweld. Once the weld is cooled, and the cooling is the most important part about HDPE welding. What happens in the welding process is that as the heat gets generated through the coupling and the pipe, is that the 2 polymers start to melt and get soft. And once they are at the 220 degrees and they've got the correct soak period, is then the weld will stop, and then they have to then cool down. And it's in this cooling down process that the weld actually happens. That is the most important part of it, is that the molecules start to contract and go back to their original state. And that is what makes sure that that pipe is going to be a perfect joint and never come apart. Once you've done the 110 weld, you'll remove the little shroud, and then you'll push the 160 pipe up further, and you'll then weld that. It's really important to make sure that your pipes are only scraped just before installing them, and now you're working in the ground. So to make sure that before you do the weld is that you clean the weld surfaces with acetone. Push them together and weld immediately. Access chambers. The access chambers are different to a manhole, is that the idea is that they are totally sealed and welded. There's no ingress of water and no leak. We manufacture the chambers with a fall to them, and we weld 160 stubs onto the chamber, and this will take all of the drainage points. On the top of the chamber is that we have a sampling tube, and that is at the deepest part of the manhole, so that once the junctions have been put inside the chamber and it's welded closed, is that sampling tube is then taken up to ground level when you're doing the backfill, and then an inspection cap is put onto that. And that way you can sample at any point to see where you do have the leak. So based on this principle is that 160 pipe will go from junction box to junction box, and the water would always, if there is a leak somewhere, the water would always run to the next junction box, and eventually it'll go out to somewhere where it won't be a problem, so far enough away from the building that if there is any sort of leakage, it won't be an issue. In real, the D3 installations is that they'll want you to have that into a little pumped sump, and they want that water to be pumped so you can see it, that you'll know there's a problem. So this document was produced in 2012 after many years of consultation, and some great work has been done on it. But it's, as I say, it's an old document and a lot of technology has changed. So safety is a top priority. However, it's often influenced by cost. And we've seen a lot of mixed installations where making up a gully out of HDP is quite expensive. And so they'll put in a PVC gully at that point, and then that's got a rubber joint and of course can come apart. But we've seen a big shift in specifications for Dolomite areas, and engineers are definitely looking at better solutions. I think the most important part is if you have to sign off and put your professional liability number and your reputation on the line, what do you do? So this is sort of what we're seeing happening at the moment. Welcome to Tech Talks. Today we're looking at drainage installations in Dolomite areas, and we are going to be installing a section of pipe over this wall face, which will be just under 20 meters long. We are going to secure the pipe at the two ends, installing a bracket on either side of this bushing that will then let the pipe collapse between the two brackets, and we will see the effect of the strength of the pipe and what is required in order to make sure that we don't have failures in Dolomite areas. To do this, we are going to use a heavy-duty sticker brackets and fixed points, which we will fix to the wall. And as Untitled is a training company, is we'd like to just include a little bit about fixing and drilling and setting of anchors. We often see that this is done incorrectly on sites. In order to be able to pick at your threaded rods to ensure that you have the correct force. The drill is now used to set the anchors, and you just drill it like you would normally drill, and the hammer action will set the anchor. And the anchor is then set. The pipe is now being fixed on the two ends. No brackets in between, supported temporarily by the tie downs. All the tie downs will be released simultaneously to simulate a collapse in the ground. The dolomite becomes saturated, it eventually degenerates and your ground will collapse. This collapse happens suddenly, and we take anything that is fixed to it down with it into the sinkhole. Pipe is now being filled with water. Once the pipe is full of water, we will release the belt simultaneously, and we will watch what happens with the pipe as it is blocked. The effect of this is that we'll have 176 kilograms of water in the pipe, and we will see whether the pipe will actually fall off the wall or whether it will be suspended. The more interesting is to the integrity of the joints and to see if it is able to span this distance. We'll then put it through some further abuse by adding a little bit of weight and swinging on it, and we'll see how it copes with that. Then we'll do some real South African testing. At this point, we had a whole lot of guys swinging on the pipe. That's 85 kilograms hanging on the middle. This has left a section of pipe 18.4 meters long without any support in the middle, with the total weight of the water of 176 kilograms plus 85 kilograms of tundra hanging and swinging in the middle.
The quality of Geberit HDPE has been tested and certified in independent labs in different countries. In addition, Geberit carries out random sampling for all systems regularly in its own test lab. The connections are given special attention in the test lab. The electro-weld sleeve is subjected to a tensile load of over 1,300 kilograms and withstands it. Simple butt welding must be able to withstand the same high loads.
Of course, they're not good enough for us in Africa. Objective: test the electrical coupling to see how much force it needs before it fails. We've hooked it onto the Umpakati truck and onto a Land Rover. We'll put it into low range and then proceed to stretch it. Truck is about 5 tons, and Land Rover is a bit lighter but not powerful. Okay, we're going to give it some more vim and we'll try this time and see if we can get it to fail. That's not going anywhere. Okay, we've connected the one side to the truck, and we have our 19 meters. We're just going to take the tension up. Okay, this time we're going to give it a little bit of a running start just to see what will happen. We're connected. Well, it's clear that no Dolomite sinkhole is going to destroy this Geberit HDP. All the joints are still perfectly intact. Has mangled this pitching a little bit. wondering whether you use with him again. So we're running out of time as always. We tried to break that pipe for about 2.5 hours, and it wasn't going anywhere. So we're seeing more and more often is that engineers are now specifying a single pipe installation with using the Geberit HDP. And on the side here, I've given you the welding charts that are really important when you are doing HDP. We see a lot of failures, and every time it is due to poor workmanship. The most important part is that the oxide layer needs to be scraped off. You must stick to the welding tables. And important when you bring in the two faces together is to bring them together over a period of 5 seconds and bring the pressure up. Just don't slam them together because that pushes all of the molten HDP out of the side of the weld. So that's our presentation, and half an hour is always very difficult to try and get it done. Thanks to Geberit for always assisting us in making this possible, and for Sikla for their supports. The supports that broke off the actual nipple snapped, and that was a result of 4 of my guys hanging on the pipe trying to bounce up and down. So hence the tie down to support the brackets. What an incredible product. Any questions, anything anybody would like to know, anybody that needs to know anything about Dolomite or the containment pipe, please feel free to email me.